Hello everyone, this is Shyam Babu, Assistant Professor, Electronics and Communication Engineering, MLR Institute of Technology, Hyderabad. Today, we are going to learn about need for modulation and types of modulation techniques. So, before discussing about need for modulation and types of modulation, once revise what is modulation. What is modulation? Observe. Here I am taking the block is modulator. It needs two signals. One is message signal. I am using M of t, otherwise message signal. Nothing but our information signal, and one more side it is carrier signal. So message signal M of t, I am representing the carrier signal C of t, and the output of modulator block should be it is equal to modulated signal. That should be either S of t, what is our representation. But here now, the modulation needs two signals. One is message signal and the second one is carrier signal. What is the definition of modulation? The modulation is defined as the high frequency carrier signal is varied according to instantaneous values of message signal. So again I repeat. The high frequency carrier signal, remember mathematically or graphically, the carrier signal can be represented sinusoidally. This is the carrier signal representation. So, the high frequency carrier signal is varied according to instantaneous values of the message signal. Remember, graphically, the message signal can be represented like this. So, just observe the waveforms difference between message signal and carrier signal is, in the case of carrier signal, the time gap between the cycles, this is one cycle and this is another cycle. The time gap between the cycles is very less. That means the time is always inversely proportional to the frequency. Once the time period is very less means the signal frequency is more. That's why it is called as a high frequency signal. It is called as a carrier signal. Then here the time period is very high. Then you know very well the time is inversely proportional to the frequency. The time period is very high means the frequency is less. Then it is called as a low frequency signal. It is called as a low frequency signal. That means the information signal is low frequency signal and the carrier signal is a high frequency signal. Then the definition should be observed. The high frequency carrier signal is varied according to the instantaneous values. Remember, this is very important. What is that? Instantaneous. So, instantaneous values means, what is the meaning of instantaneous values? The instantaneous values are either amplitude, next one frequency. Once you know the frequency, then automatically you know the time period, and phase. These are the three instantaneous values. That means the high frequency carrier signal amplitude is varied according to the message signal amplitude. That is the meaning, amplitude varying. The frequency of the carrier signal is varied according to the frequency of the message signal. That is the frequency value, instantaneous value. The phase of the carrier signal is varied according to the message signal phase. That is the instantaneous value related to the phase. That is nothing but the instantaneous values are amplitude, frequency and phase. Therefore, with respect to these three things, we develop a definition of the modulation. The modulation is defined as the high frequency carrier signal is varied according to the instantaneous values of the message signal. That is called as a modulation. Then here the modulator is the block to combine the message signal as well as the carrier signal, and it generates the signal should be a modulated signal. A modulated signal. That means the message signal and the carrier signal can combine, the resultant signal should be modulated signal. Therefore, here one thing here you observe, which signal having the information, either message signal or a carrier signal. There is no doubt the message signal contains the information, the carrier signal just supports or just boosting the message signal information. That means the carrier signal does not having any information, the total information consists the message signal. Therefore, to travel to the long distance, to reduce the noises, on that situations, the carrier signal should be helpful. That is the importance of the carriers. Always remember, the carrier does not contains any information. The actual information consists in the message signal only. Then once you can combine these both the signals, and the output signal should be modulated signal with respect to the instantaneous value. That is the modulation. Then what is the need for modulation? Once you know the definition of the modulation, especially in the communication system, we know very well. The communication system means transmitting the information from the transmitter to the receiver. Therefore, what is the importance in the communication of modulation? Observe, the first point is a reduction in the height of antenna. That is the first point. And the second one is avoids mixing of signals, increase the range of communications, multiplexing is possible, improves quality of reception. Therefore, what is the need of modulation? The first one is reduction in the antenna height. Remember, whenever you are transmitting the radio signals, definitely you need an antenna. The antenna is a transducer. Nothing but whenever transmission of the radio signals, we need an antenna. The minimum antenna height should be multiples of the lambda by 4. Observe, very important thing. The minimum transmission height is multiples of the lambda by 4. Then for example, here the thing is, what is the importance of modulation? On that case, the first point is a reduction of in the height of antenna. If you can take, this is the tower, this is the antenna for example. This is the length should be more. Here I am taking one more antenna here, the length of that antenna should be less. Then observe here, which one is the better one means definitely you need to understand the modulation process, because this length of this antenna is very less, it is also transmitting the signal with the properly. And this height is more, it is also transmitting the information. But what is the importance of modulation? When you reducing the height of the antenna, it is the advantage or not? Therefore, the transmission height is multiples of the lambda by 4. If I am transmitting, the frequency of the signal should be equal to 10 kilohertz of the signal. Remember, the signal strength or the transmission signal frequency should be equal to 10 kilohertz. Then observe here, the length of the antenna is always proportional to the wavelength lambda. Then observe here, you know the lambda should be equal to lambda by 4 because the minimum height is multiples of the lambda by 4 of the antenna. Therefore, observe, when you are transmitting f is equal to 10 kHz signal with a lambda is equal to lambda by 4, You know the relation lambda is equal to C by F. You know the value C is equal to 3 into, you know the C value, C is equal to 3 into 10 to the power of 8 meters per second, and you know the frequency F is equal to 10 kilohertz. Therefore, you find the lambda, nothing but the height of the antenna. Remember, when you taking lambda is equal to lambda by 4, then you can write down C is equal to 3 into 10 to the power of 8 by 4 F. Nothing but 3 into 10 to the power of 8 by 4 into F value is 10 kilohertz. Therefore, that is equal to, observe, this is approximately equal to 7,500 meters. 7,500 meters. Nothing but it is 7.5 kilometers. Observe, this much length of antenna is practically is possible? No. Therefore, you need to reduce the antenna height. You need to reduce the antenna height. Then automatically what is the alternate thing? Definitely you need to increase this frequency. Here the question should be arises, sir, the frequency can be increasing means, what is the meaning means? Here the 10 kHz or 1 kHz actual frequency I am not disturbing, but I am multiplying that small frequency or our information signal frequency with a high frequency signal. That high frequency signal is a carrier. It is multiplied with the actual information signal. For example, that should be equal to 1 megahertz. Previously, I am taking F is equal to 10 kilohertz. 10 kilohertz means, observe here, in this one, it is the multiplication of the carrier, message signal into carrier. Here also, F is equal to 1 megahertz, message signal into carrier. Then observe, if you replace this 10 kilohertz with 1 megahertz, you know 1 megahertz means 1 into 10 power 6 hertz. Then you can substitute the value. That means 3 into 10 to the power of 8 by 4 into F value should be here 10 power 6. This value should be equal to approximately 7.5 meters. That means when you transmitting the F is equal to 10 kilohertz, the length of the antenna should be equal to 7.5 kilometers required, the antenna length, height of the antenna. If you transmit F is equal to 1 megahertz, the antenna height should be 7.5 meters only. That means whenever you are increasing the frequency, the antenna height is reduced. How it is possible? Actual information is 1 kHz or 10 kHz or 20 kHz only. But I am multiplying that 20 kHz or 10 kHz with high frequency signal like either 100 kHz or 1 megahertz like that. Then automatically that is called as a modulation. Therefore, the first point is reduction in the height of the antenna is possible with the help of modulation. That is the importance of the modulation scheme. Observe, 10 kHz signal you can transmit, or 10 kHz signal means 7.5 kilometer height will be needed. It is practically impossible. Then I am multiplying that frequency with, for example, 1 megahertz I am taking. This 1 megahertz consists actual information as well as carrier. The carrier is helpful. That is the definition of the modulation. Then it should be equal to 7.5 meters only. That means simply the antenna height should be, it is reduced to the 7.5 meters from 7.5 kilometers. Between the frequency should be 10 kHz to 1 megahertz. When you are changing 10 kHz to 1 megahertz, the frequency changing is nothing but modulation process. That is the first need for modulation. What is that? Reduction in the height of the antenna. Then go for the second one, avoids mixing of signals. What is the meaning of avoids mixing of the signals? For example, I am taking a transmitter, otherwise I am taking the 3 users at the transmitter side. Here transmitter 1, this band of frequency is 0 to 20 kHz, and the transmitter 2, it is also 0 to 20 kHz, and the transmitter 3, and it is also 0 to 20 kilohertz. These three signals having the same frequency, then observe this is the receiver. For example, the transmitter transmits the information to the receiver with the same frequency. Then observe the signal, which signal is received by the user, either transmitter 1, either transmitter 2, or either transmitter 3. And for example, if you transmit the three signals at a time, which signal can be received by the receiver? It is a efficient signal. It is an efficient signal, means definitely it is not a efficient signal, and we are not concluding which transmitter sends the information also. Therefore, in this case, to solve this problem with the help of modulation. How means? For this band of transmitter 1 frequency, I am taking carrier frequency of C1, having certain frequency should be, for example, 200 kilohertz. And I am taking one more carrier frequency of C2, that is, for example, 300 kilohertz. I am taking transmitter 3, this frequency of C3 is equal to 400 kilohertz. As per the definition, the carrier signal is varied with the message signal, then 200 kilohertz with the transmitter 1. Automatically, what is the frequency? It is different one frequency. For example, it should be fx1, for example, otherwise fr1, next one fr2, and next one fr3. These three are different frequencies because the carrier signal is varied, the carrier signal is different, it is multiplied with the actual information, automatically the frequency is varying, it's not the same. Previously, when you are not taking the carrier frequency, all the transmitting frequencies or all the modulating frequencies are same band. When you are transmitting the same band of frequencies, we are not identifying which band is received by the user at the receiver side. Then, when you are multiplying with the carrier with the different frequencies with the transmitters, then the process is called as a modulation. Therefore, to avoid the mixing of the signals, with the help of modulation process, to avoid the mixing of the signals. So that is the importance of modulation, need for modulation. The second one is avoids mixing of signals. And go for the third one, increase the range of frequencies or increase the range of communications. Remember, when I am taking f is equal to 10 kHz frequency, in the next case I am taking f is equal to 1 MHz frequency, and the third I am taking f is equal to 20 MHz frequency. Then observe here, when the low frequency signal means comparing these three signals, the low frequency signal is 10 kHz. The next one is 1 MHz. After that 20 MHz. Observe here, this 10 kHz signal can be transmitted to a long distance. Long distance means, for example, if you take 100 meters or 200 meters or 1 kilometers of the distance, when you are transmitting this 10 kHz frequency signal, that's having some attenuation problems. The signal quality should be reduces, and it is also not possible to transmit a long distance a low frequency signal. But my intention is to transmit this low frequency signal to a long distance is possible with the help of modulation process. With the help of modulation process. How means? Just you can multiply this 10 kHz with you can multiply this 10 kHz signal with, for example, 1 MHz or 10 MHz. Then automatically the frequency of that signal should be more. Automatically the strength is more, then it is capable to transmit a long distance. Therefore, here actual signal is 10 kHz only. I am multiplying a high frequency signal. That high frequency signal is called as a carrier signal, is multiplied with actual information signal. The process is called as a modulation. Therefore, that is the need of modulation to increase the range of communications. Simply we can conclude like this. Other examples also, 1 megahertz or 20, whatever you can take, either low frequency signals, you can transmit a long distance. For reducing the noise, we need a modulation process. Therefore, increases the range of communication is one of the important with respect to modulation. The next one is multiplexing is possible. What is the multiplexing? If you take the 2 or more signals to transmit on a same channel simultaneously, taking the 2 or 3 signals, you can transmit those 3 signals on a single channel simultaneously. For example, F1, F2, F3. These 3 signals, for example, this one is 1 kHz and this is 2 kHz. Otherwise, this is also 1 kHz if you take. F3 also 1 kHz, otherwise 20 kHz. Between 0 to 20 kHz it is called as audio frequency if you take anything. F1 is 1 kHz, F2 also 1 kHz, F3 also 1 kHz. These 3 signals I am passing through a single channel. This is the single channel. Channel is nothing but a medium, nothing but a transmission medium. Then observe, 1 kHz signal is given here, 1 kHz signal also is given here, this 1 kHz signal also is given here. Then tell me, it is passing through on single channel means is passing, but interference is happens, overlapping is happens. To avoid that, the modulation is needed. It is possible with the help of multiplexing. In the multiplexing also the modulation is helpful. How means? Observe here, especially when you take the example is TV communications. In the TV communications you observe the so many channels, each channel having the 5 MHz frequency for example. For example, if you take some channel names, ETV it is the 5 MHz and Gemini TV it is 5 MHz. For example, if you not maintain the proper guard band between these two, what happens? The channels are overlapped to each other. Therefore, to avoid the overlaps is possible with respect to the modulation process. Okay, simply already in the second point we discussed avoiding mixing of the signals, FDM process, frequency division multiplexing. Here also simultaneously you can transmit the signals is possible with the help of modulation in multiplexing. This is also one more advantage need for modulation. And the next one is improves quality of reception. So especially when you are observing the digital modulation schemes, either PCM, by using sampling and quantization process, we are reducing reducing means the distortion levels. For example, the amplitude level should be 1.25 volts or 3.08 volts. Then when you are taking this value should be 1 volt or this value should be 3 volts, automatically 0.25 volts or 0.8 volts, 0.08 volts, that small amount of fluctuations or small amount of voltages can be reducing using the sampling and quantization process. Nothing but the noise should be reducing. It improves the quality of reception. It is also possible with the help of modulation. It is also possible with the help of modulation. That means improves the quality of reception means reduce the noise, reduce the attenuation, reduce the interferences in the channel. These all are gives improves the quality of reception is possible only with modulation process. That is the importance of the modulation process that should be helpful in communications more. Therefore, these all are modulation, need for modulation. What is the first one? Reduction in the height of the antenna. Second one is avoids mixing of the signals. And third one is increases the range of communications. And fourth one is multiplexing is possible. and fifth one is improves quality of reception. In these three aspects, the modulation is needed. Then after that we go for the next concept, types of modulation. Basically, analog modulation technique and digital modulation techniques. Analog modulation and digital modulation with respect to message signal. The message signal should be, it is a continuous, it is analog. The message signal should be in digital form, it is digital modulation schemes, and also based on the carrier shapes. In the analog communications, we are taking the carrier is also continuous. In terms of some pulse code modulations, for example, in terms of some PWM, PPM, on that situations we are taking continuous pulse train also as a carrier signal. In further classes we discuss individually with respect to carrier shape how the message signal should be varying. So right now the types of modulation should be a continuous wave modulation and a pulse modulation. Again, the continuous wave modulation should be amplitude modulation, angle modulation. Here the angle modulation should be frequency modulation and phase modulation. Observe, this total thing should be under the continuous wave modulations, means the message signal as well as the carrier signal both are continuous. In the case of pulse modulation techniques, we are going for pulse amplitude modulation, pulse width modulation, pulse position modulation. If you take the message signal continuous, if you take the pulse train as the carrier, on that situations what happens with respect to the carrier is a pulse train. If you take message signal is a digital and carrier signal is a continuous, on that case what happens? This classification is explained the types of modulation. In the further classes we are taking individually what is amplitude modulation, what is frequency modulation, and what is phase modulation, and the definition also. Then what is the summary? What learned today's class means? In the today's class we discuss about the need for modulation concept and types of modulation concepts. In the coming sessions we discuss about the continuous wave modulation. Under the continuous wave modulation we discuss the AM, FM and PM. Thank you very much.